So today's talk is going to be on automating attack simulations in the cloud. As to why I'm here talking about it, I'm currently the cloud security lead at F-Secure Consulting. So while I've been focusing on AWS for a long time, when I'm not doing AWS, I spend a fair bit of time working with a variety of organizations to help them build their attack detection capability. So this is sort of a confluence of those two areas of interest for me. As to what we're going to be talking about today, first up, the challenges of cloud detection, so how this differs from on-premise. Next up, what we can do to make it easier to automate a lot of these attack simulations, and some tooling I've developed. And then next up, how to go about implementing a lot of this in your organizations. So before I go too much further into this, I just wanted to put a few things up about attack detection for those who are less familiar with the field. I'm sure we've all seen diagrams like this. At the end of the day, we can catch a lot of the basic stuff with automated tools. I'm going to put guard duty into that, but sort of antivirus on-premise is the classic example. Really, what I'm aiming this talk at today is on the top end of things, the sort of the serious organised crime groups and nation states. And the thing that comes with that is the need to be able to both have efficient and effective processes within your detection function, your SOC, whatever you call it, but also to be able to proactively go out and hunt down new instances of attacker activity, TTPs, things that have been released recently, new blog posts and so on about new attack vectors, be able to go out and proactively hunt down instances of those use. The problem is that the investment required to get up to that top end is significant, and most organizations can't afford it, to be blunt. So as an industry, we need to work carefully on how we can bring that barrier down, how we can lower those costs in order to make everyone better and secure the cloud as a whole. So one of the key problems we've got really is that the on-premise detection space is well understood. We've been working on this for 20, 30 years in many cases. We've been defining standards, defining attacker TTPs, building detection stacks for a very long time. What that looks like is pretty well known at this point. The problem then comes in the cloud space, where it's a much less mature market. We're still understanding a lot of what an attacker is likely to do, especially at the higher end of the attack scale, the skill set scale. So there's been a lot of effort being put into this by a variety of organizations over the last little while, some interesting security research coming out, but we're still playing catch up essentially versus on-premise. So one of the things I wanted to dig into a little here is how cloud detection differs from what we're used to on-premise. And one of the key points really we've discovered is that there's the concept of uncertainty of malicious intent. So on-premise, we had things like someone's running some obvious ransomware. We've got mimikatz executing on a box, things we can signature on, things that we know are bad, things that we can easily fire alerts off of. That exists a lot less in the cloud. Context becomes key for everything. So we're looking at anomalies by environment. So this is even within an organization. What is anomalous in one cloud account might be perfectly benign in another. So that's going to be an ongoing problem for detection teams who are used to building generic detection capability. On the plus side, visibility is much easier. Things like organization-wide cloud trails in AWS make it very easy to make sure that you have all the relevant logs that you need in order to perform this detective activity. The downside as well, with the performance of the APIs, or the availability of all these APIs allowing us to automate things, is that we're seeing attackers start automating their attacks too, right? So a great example is compromised AWS credentials on GitHub being used for Bitcoin mining. We heard quite a lot about that earlier, but one of the interesting things from my perspective is that we're seeing attackers use continuous delivery pipelines to spin up their mining rigs in order to speed up how quickly they can go from key compromises to mining activity happening in the account they're targeting. And to really highlight and hammer home the difference between our understanding of what on-premise attacks look like versus the cloud, this is the MITRE ATT&CK framework for Windows versus for cloud. So ATT&CK, for those who aren't familiar with it, is sort of a de facto standard at this point for defining techniques, tactics, procedures, and tying them to public threat actors via whatever open source intelligence threat intel is available. It's used by an awful lot of organizations to track their detective capability over time, track that improvement. And as you can see, it's a lot less fleshed out in the cloud than it is on premise. And that's an ongoing thing that I know MITRE are working on, as are we and a number of other organisations. That said, there's still a number of places we can draw useful inspiration from in terms of what attacks look like. Especially some of the work that's been done by Scott Piper and by Rhino Security over the last couple of years flagged a lot of really interesting attack vectors, IAM privilege escalations, all of these kinds of things. Equally for the other cloud providers, some of the guys at GitLab have been doing some great work too. So there's a lot out there to draw on for inspiration and for ideas as to what an attack's likely to look like, even if the usual data sources that we turn to for detection are less well defined in the cloud space. Next up, though, how do we validate? So let's say we've worked out roughly what these attacks are likely to look like. There's sort of a process we have to go through to first build detection capability and then validate that it actually works. There's no point in building it if we don't know whether it works or not. So this is really quite important. And I've outlined the overall process on that slide there. I think the key thing here is there's a few points of this that are currently very manual, especially in the cloud. In particular, executing the attack paths and then actually doing the diffs of, we executed this, did we spot it? What does this look like? So executing the attack paths, automating this in the cloud is even easier than it was on premise. The reviewing telemetry and alerts and identifying what use cases fired and what didn't is a little harder, but I still think there's a fair bit of work that can be done there to speed a lot of this up. And really, if we can automate a lot of this, it means that we move away from sort of the waterfall style development cycles that a lot of people use for their detection at the moment and speed things up. And so to go along with that, one of the things that I think that we've all learnt from DevOps and cloud is that treating things as code makes everyone's life better. So detection as code, to me, is something I'm very interested in. And we've seen some organizations already adapt this on premise. So Sigma, if you're not familiar with it, is a set of seam agnostic rules with a compiler. So you have a bunch of generic detection definitions, IOCs, etc. You compile those down for Splunk, for QRadar, for whatever else. And so we can maintain one central open repository for these detections, and organizations can then import them into their specific environments. Likewise, at the threat hunting end of things, we have Jupyter notebooks being published. There's some good stuff there by SpectreOps on it. And these are essentially Python data analysis tools for doing specific threat hunts around whatever threat actors we're looking at today. There was a really interesting keynote at last year's T2 conference by John Lambert on the GitHubification of InfoSec, as he calls it. This idea of leveraging open source to essentially improve the security of everyone at once by choosing it to share knowledge, share tooling, increasing the cost for attackers of each individual campaign. So on premise, there's a lot of things happening in this space for when it comes to treating detection as code. Another couple of projects worth highlighting here: Atomic Red Team by Red Canary and MITRE's CALDERA are both frameworks essentially for defining what an attack looks like or a particular TTP and being able to automatically execute them. So a lot of this work has been done on premise already, but I've yet to see much of it in the cloud space. So I sat down and we started thinking about it, and so I built a tool for doing a lot of this. So Leonidas is essentially a platform for defining and executing test cases in this space, along with defining the detection cases for it, the IOCs you'd look for. So let's say we've got a security team in an organization, we've got some analysts, we've got some red teamers, purple teamers who are going to be working on this as well. So an analyst gets onto his Twitter feed that morning and learns about a new cloud TTP that's relevant to their environment. So he defines that in the YAML-based format that we've got that comes with Leonidas, and that gets checked into a code commit repository at the moment in AWS, and we're planning on going multi-cloud in the future, but start with AWS. That then is actually processed by a CI/CD pipeline, and the test case that they've written is then built into an API that's exposed as a Lambda function. So what can then happen is the purple team, without necessarily needing to know that much about how these TTPs work under the hood, let's say we've got some analysts with less experience that we want to get involved, they can execute the attack simply by hitting these web API endpoints. And so then we can then ship the logs out of our target resources. Maybe we've got a test account set up. We can ship those logs straight out to our SIEM from there and work out whether our detection use case is fired correctly or not, whether we have the right telemetry. We can investigate further from that point. So just to dig into a little as to what this looks like under the hood. So here's an example of a test case for enumerating cloud trails. An attacker's likely to want to see if they're being monitored when they land in an account. So we define us, in this case, it's a single line of Python saying, CloudTrail describe trails, calling the Boto3 underlying API call there. And that's then baked into the web API that's exposed as a Lambda function, and we can call that via an AWS API gateway that's exposed. But also we define the detection cases here. So we talk about where the detection or the indicators of compromised IOCs are likely to live. In this case, CloudTrail. This is the case for a lot of the AWS detection cases we've been building. And so we define the event name and event source that's likely to indicate it. And we then compile these down to Sigma rules. As I mentioned before, Sigma's an open source definition framework for detection for a variety of different SIEMs and other logging platforms. So this allows us to integrate with tools that people are already using. And lastly, worth flagging off this, we can also then go away and produce some really nice documentation off these definitions. So if you've got analysts, again, who are less familiar with this, who aren't necessarily subject matter experts, we can actually dig in and we can show them the documentation to go along with it. Now, one of the other really powerful things is if we have all this defined as APIs, we can then start doing continuous testing. So we can start triggering test cases left, right, and center. Whenever we feel it relevant, we can do it on schedules. We can do it at random, kind of a chaos monkey-esque approach to detection validation. One of the really interesting things from my perspective that we've been playing with is integrating this cloud simulation capability with our existing on-premise tooling for it, and being able to simulate hybrid attacks where someone gets phished on-premise, they pivot over to an administrator's box, they steal some administrator's AWS creds, move into the cloud from there. We can simulate all of that in a completely automated fashion. So I'm just going to give a quick demo on how this works in practice. So first up, just to show, this is the API running. We expose like a Swagger interface for people to have a play with it. He says, is this actually going to show up on the stream? Oh yeah, there we go. Fantastic. So from there, if we jump over to a terminal, I also wrote just a quick script to allow you to easily script up some of these test cases, group them together. So we have a case configuration that defines the endpoint we're going to hit. So here you can see we're running in an AWS API gateway with a Lambda function behind it. And so as an attack path, we're going to work out who we are. We're going to do get caller identity, work out if we're being monitored, look at guard duty detectors, look at CloudTrail. We're going to add a backdoor user and an API key to it, and then go digging around in Secrets Manager to try and steal some secrets. So if I now run this, hopefully this all works. So first off, we get caller identity. We see we're running as a role that's attached to the Lambda function in this case. We've got guard duty running, so we might get spotted. We've got CloudTrail running, so they've definitely got the telemetry to spot us. Let's add a user anyway. So we've now got a backdoor user created. We're going to add an API key to that user. We're now going to start digging around in Secrets Manager, and it looks like, oh yeah, so we've got a secret that lives there, and we're now going to try and access that secret. And you can see that we've pulled an API key out from Secrets Manager. You know, maybe that's actually your root signing certificate or something that the attacker stolen. But you can see here we can script up entire kill chains of test cases in a very simple and easy fashion that makes it really easy to simulate a lot of attacks quite quickly when the need arises. So the other interesting thing that comes off this from my perspective is that we can also start doing essentially continuous integration of our detector capability. So Leonidas also has quite a robust logging function built into it. So every test case that is executed is logged with the test case, the parameters that were passed in, timestamps, the identity it was executed with, and so on. And we can ship those logs straight out to our SIEM, along with all of the logs from our target resources, our test environments, and we can write our own tooling on top of that to start querying for, have we spotted this test case? Have the detection cases fired correctly? We can run all of that in an automated fashion as well by essentially diffing the logs that come in from Leonidas against the test cases that are fired in our SIEM or our alerts that are fired off. But how do we get started in an organization with this? I think there's a few key things to bear in mind here. First off, threat model your environments. it really is important before you start that you have a clear idea of what the attack paths are likely to be through your environment, key attacker actions that are likely to take place on multiple attack paths, and that gives you a starting point. You know where to prioritize things. This is going to be a journey, so you've got to start somewhere. Pick a few key points. Then codify them in some fashion. Obviously, I'm biased here. I've built a tool to do all of this, but even just writing simple Python scripts so that they're defined somewhere is a great start. You can share those amongst the team that way. Before you start executing these, make sure that the telemetry you need is actually available to your defenders. There's no point in executing a load of attacker actions if we know the defense team aren't going to spot them. Our time's best spent getting the telemetry, the log data into their log processing platforms, into their SIEM. And then once we know we've got that, then we should execute these attacker actions, ideally as whole kill chains. It makes it more realistic that way. But Atomic can work quite well in certain situations too. And then verify that your detection cases work as you expected them to, and then plan further improvements accordingly. In terms of prioritization, I think there's a few key things, if you don't really know where to start, that I'd flag. In particular, anything that is highly privileged and infrequent. So anyone trying to mess around with your guard duty, your CloudTrail, your Azure audit logs, anything like that, that's a great place to start. Equally, things like manipulating IAM, especially from user accounts or roles that don't typically do that, or anything at the objective end of the kill chain where we can spot an attacker going after specific data sources that we know we care about. Maybe you've got a database that holds loads of really important information, so monitoring access to that quite carefully would be a good idea. So pick out things closer to the objective end of the kill chain. They tend to be higher fidelity, the higher signal to noise ratio. Makes it easier to spot when you're first starting out. So one other important thing to bear in mind with all of this is that detection is a journey. Effective detection is a constantly moving target. Attackers change their TTPs all the time. Your environments will shift underneath you as your developers move fast and break things. So treat it as an ongoing development project. Get started somewhere, but plan for it to work on a kind of a continuous cyclic basis. We found Agile, Scrum, these sorts of software development methodologies work pretty well for building attack detection capability as well. So I'd adopt that kind of approach rather than planning out sort of big monolithic waterfall development life cycles for all of this. So to conclude, I think the cloud brings all kinds of interesting challenges to it from a detection perspective. With the benefits of automation, there's a lot we can do there to really speed up our reaction times, make it easier for us to simulate these attacks, quite a few other things. That then does come with downside because the attackers can also automate everything too. So often our window of response time shrinks significantly compared to what we might be used to on premise. So building out your automation, both from a detection perspective, but also from a response perspective, is going to be really critical, I think, in the long term. And lastly, Leonidas. So as of about half an hour ago, we've got a GitHub repository up at github.com/fsecurelabs/Leonidas. We've got both test and detection cases up for AWS. There's about 34 test cases on there at the moment, and more to come, along with Azure and GCP support in the long run as well. That's already on the roadmap. So keep an eye on it, give it a try. Let me know how you find it. I won't say there's not going to be any bugs. We've battle tested it on a couple of engagements now, but it's likely to still have the odd one or here or there. So raise GitHub issues, and I'll do my best to get it fixed as soon as possible. Thanks for listening to me. There's a feedback link at the bottom there if you'd like to leave me some feedback. Otherwise, I'll take questions at this point.
Thanks, Nick. You've actually proactively answered the most common questions around open sourcing and support for GCP. Though I would ask any sense of timeline on when those other things are going to be released.
Timeline for GCP's next on the to-do list anyway. So I'd expect sort of months rather than weeks for that, but hopefully not too many months. I know we've got some use cases for Google Cloud and detection assessment coming up fairly soon. So I'm hoping we'll have that out, call it sort of 6 to 12 weeks, something like that. But it's actively on our roadmap and being worked on.
Awesome. Are there ways we can help? I think, are there pull requests or particular features you're looking for support in?
Yeah, absolutely. So I think the big things we're looking for support on is expanding the set of definitions of attacker TTPs. We've got quite a few in there based on things that were either immediately needed for environments we were testing, or needed for were easy to put together, and things that I could quite quickly write test cases for. So some time spent putting together some pull requests for some other test cases that are useful to you in your environments would be very useful indeed. Basically, the more of these definitions we can build up, and especially if they're all being open sourced, the better everyone gets at spotting this stuff, and the harder we make it for the attackers, the more secure everyone is, right?
Well, good news on that respect from Jen Burns, who is the attack lead for Cloud at MITRE. She tells us that a new release is coming out on July 8th with new techniques, so that should provide fodder for you.
Oh, fantastic. Yes, we've actually got some conversations about to start with MITRE on a few things off the back of some client engagements. So I look forward to see what that looks like, and I look forward to working more with them in detail in future.
And then just one more question, which is in terms of brainstorming simulation use cases and doing the threat modeling, how do you see people getting management buy-in or justifying the time required to do that work? Because it can be fairly time intensive, and it's not always obvious how it provides immediate value. So how do you, I guess it's a question of like, how do you approach threat modeling from a timing and justification perspective?
So that's a very good question, and it's one that I'm not necessarily best placed to answer, because typically by the time it gets to the stage where I'm involved in threat modeling something, someone's found some money to go buy a consultant. That said, our experience with working with organizations on this has generally been that especially things like penetration test findings of environments, things like that can feed into some initial lightweight threat modeling based on something you can do with an hour's worth of time with a couple of you in a room and a whiteboard, and that might be enough to get you started. Other than that, essentially proving to management that we currently don't know what we're trying to detect in the cloud by not spotting things on a pen test, for instance, is a great way of doing that. But generally, demonstrating that you're lacking visibility compared to what you're used to on premise, I think can be a really powerful message in convincing people to give you a bit of money. As I say, a lot of this just needs to start somewhere. You don't necessarily need to put a huge amount of time investment up front, especially if you've already got the logs coming in. One of the biggest blockers for a lot of organizations we work with is just getting all of their CloudTrail logs or Azure audit logs into a sensible place for them to do detection on it. If you've got that, just find an afternoon or two and get started somewhere, however small it is.
That makes a lot of sense. One more question on that threat modeling and finding detections piece, which is, you mentioned the value in MITRE ATT&CK. You've mentioned looking at your CloudTrail logs. Are there other sources or threat intelligence feeds that you found particularly valuable for sparking this sort of research or patterning?
Yeah, absolutely. So there's a few that I'll flag specifically. I think as much as I like to joke about Guard Duty basically being the antivirus of cloud, it is still valuable. It will still catch a lot of low-hanging fruit. So definitely have that enabled if you're in AWS. VPC flow logs or NSG flow logs in Azure are still valuable, especially in virtual machine heavy environments. After that, I'd start looking at things like S3 object level logging, Lambda execution logs, that sort of thing, for things that aren't going to generate vast amounts of traffic when you turn that on. That's always a bit of a trade-off, that one. And lastly, if you're running Kubernetes, it's well worth turning on the Kubernetes audit logs and ingesting those. We've had a fair bit of success spotting some quite interesting attack techniques in those logs as well.
Well, great. So thanks very much. We'll be taking about 5 minutes. We'll be back at 3:30 Eastern with Kat Traxler talking about GCP primitive roles. So thanks very much, Nick.
Thanks for having me.